My name is Brian Burton. I'm the president of ATT Metrology Solutions. At ATT, we use a variety of laser products and devices to inspect things for quality. And one of the ways that we do that is by deploying drones and ground-based scanners using LiDAR technology, which is light detection and ranging, to send a laser pulse out and then check time of flight for that laser pulse to come back, and that measures distance. And that's important because we're out here leading a property development project in the forest, and we can create a digital twin model of this property. And that really becomes powerful when we get into applications such as architecture and land development with moving dirt around, and also forest management when we're trying to remove trees and thin trees for fire prevention and vegetation fuel reduction.
My name is Reed Wendell, and I am the owner of Angeles Forestry. We are on small forest landowners' property in between Port Angeles and Sequim. It's about a 20 to 25-year-old stand of mixed conifer and hardwood. We're doing a pre-commercial thin, which is a thinning that doesn't return revenue to the landowner, but improves the health and stocking of a forest in order to grow a better stand of trees in the future. Looking at this forest, I see a stand that was planted with Douglas fir, has regenerated naturally in a mix of hardwood and conifer species. It can be improved by thinning out less desirable species, keeping longer-lived conifer in order to have a more healthy and more resilient forest in the future. The Department of Natural Resources offers landowners cost share funds to help split the cost and encourage forest thinning and forest fuels reduction. The hope is that the funds are used in ways that make lands more resilient to climate change and less susceptible to forest fires. So in this stand, the thinning is going to be both removing trees to improve the health of the leaf trees. We're masticating and removing the thinned material in order to reduce the fuel load on the forest. So if there was a fire, it will be less catastrophic and more easily suppressed in order to both protect the forest, but also home sites in the area.
The drone I'm flying today is a BLK-2Fly by Leica. It uses their ARC scanner just attached to a quadcopter, so you can do aerial LiDAR scans. As the drone is flying over a canopy, it is shooting out a bunch of tiny little lasers, and it waits for the laser to bounce across any surface and bounce back, so it knows the distance between that, and when it gets that distance back, it creates a point in space. Once you create enough points, you kind of get a 3D map or a cloud of points. So once you go into software, you can kind of see forms of shapes. The ARC rig, as we're walking around, it's able to grab the underneath of a canopy. We're able to grab more detailed values of the terrain itself and any shorter trees that could be under the larger canopy. So we can kind of get a more detailed value of how many trees are actually in an area. With combined powers of the aerial scans and the ground-based scans, together we can get a complete picture of an area. So with the aerial, we can get the tops of trees and how tall that they are. And with a ground-based, we can get a very detailed level of the floor. So together we can make one whole composite of a full tree or a full set of forestry area.
In addition to the LiDAR equipment that we're using to digitize the property for planning purposes and improve forest management, we've also chosen some unique features of equipment for the actual clearing and thinning work in the forests. We've selected excavators to aid in pulling trees down in the cleared areas in combination with skid steers that use forestry mulchers to mulch up the understory of the forest floor to create a very clean finish and reduce the forest fire fuels that are very detrimental in the event that a forest fire breaks out. Once we've created a digital representation of a property, we can start to monitor things like erosion control, excavation planning, and forest management. And if we look at some of the tools that are used for those applications today, they're very archaic and very manually intensive. And so we can come in and do a timber cruise, and we can do it virtually with the model that's been created, doing such things as measuring the quantity of timber, the size of the timber, the species of the trees. And we have a record that if there's an event such as a windstorm or a forest fire, we can come in and do a before and after comparison to identify the content that was damaged and quantify the amount of damage that took place in that property. It creates value for architects in allowing them to showcase a different homeowner's property and build plan on top of the topography and the as-built condition that we scanned it with, and to help them visualize that, not just for the construction planning, but for the visualization of placement of buildings and homes for that property development. It also helps to plan for timelines. We can check for percent complete when earth moving equipment comes in and starts to create cleared areas that we can check and monitor progress for the project management side and construction management side. So it's super powerful to use these digital tools to have a digital representation of the property that we're developing. If you have a property development project and you want to leverage the power of the digital twin in your planning process, you can reach out to us on the web at attinc.com.